right. We'll probably be done with chapter 9 today. Sometimes when I break the class up into 3 units, that's the end of a unit. Then we do an exam, and then we keep going. I've contemplated asking if y'all would want to do an exam at the end of this chapter, and then we could just blow off having a final, right? Otherwise, what we're going to do is we're going to have a final, and it's going to have a little bit more information than where we're stop right, 1 or 2 chapters more. Anybody have any opinions? Stop at chapter 9, have an exam the week after Thanksgiving, and then whatever we do after that doesn't show up on a final, we have no final, or do we blow off the idea of an exam and we just take a final? You have it. Pardon?
That's great.
Yeah. Lynn, got a preference?
Do the exam over chapter 9.
Up to chapter 9? Okay, so if we do that, if there are no complaints, then that would mean...
what you said.
Yeah, I would agree.
Oh, good.
Yeah. So that would mean that we'd have an exam on the 29th, and that would mean that when it came down to the week of the 18th or whatever, we wouldn't have to do anything. So we'd have 2 weeks of lecture after that, and then we'd be done. I kind of like that idea.
Tuesday.
While I'm looking at the screen, but I can just look at...
I signed up for your advanced class, and now it's showing on my screen. When I
Oh,
get to
excellent.
Choose.
I hope a lot of y'all will take advanced Java. Otherwise, Lynn will have enrolled in it, and then the class will be canceled. There are other Java courses that feed it, of course. Alrighty, so let's see that.
It's showing a strictly internet one, if I'm understanding it correctly.
No, there should be 2 of them. Let me take a look.
I mean, 2,
Just a sec.
yeah, in addition to the.
Yeah, okay. So, chapter 9 ends on unit 2. Let's do an exam over unit 2 on November, what did I say, 28, 29? 29.
So we'll be continuing after chapter 9 with just no exam.
Right, yeah. No, we can't just stop class.
Well, yes.
We could play.
Where do we plan to get to?
Good question.
So I was curious if there could be not necessarily like blow off, I'm saying like a recovery day, because I'm still kind of confused on some, what I'm trying to say here, some topics, and I was curious if I could have some additional class being on time for it.
Yeah, can you text me or mail me a list of what you want me to cover? Because we're going to finish this chapter today, and then we could work on it like on Thursday. Does that make sense? We could have like a, a free form, talk about whatever we need to talk about day on Thursday if you think you could shoot me a list of topics to cover.
All right,
Does that make sense?
yeah, thank
All
you.
right, cool. So we talked about arrays of objects. An array of objects is just like any other array, except that when you create it, it's just full of nulls. It's full of spaces where references to objects could be stored, but until you actually create the objects themselves, it's just an array of nulls. And I think I demonstrated that a couple of different times. Wow, are we really going to be done this fast? We covered 2-dimensional arrays. Yeah, I guess we did. So anyways, a for-each loop. A for-each loop is an alternative to the traditional for loop. We've been using this actually. If you have an array, what you do is you use for I like this C# language because it actually has a word for each. And then you give a data type like int, followed by a variable name, and then colon, and then the array name there. And it simplifies the writing of for loops that reference arrays. And even cooler than that, if the data type later changed to be something else, like a stack or an array list or something like that, the same exact syntax will work unaltered on those more abstract data types. So when you see something like this, you just read it for each element reference in array reference. No, I'm not going to say that. I'm going to say for every int in array, right, or something like that. For every int, and then I'm going to give it a name, in, and then I'm going to give the array name. So if I have a series of numbers, I'm going to print them out. I have two ways of doing it. One is by index, and the other is with the for each loop. For each loop is easier. For every int, or for every value that's in the array, then you could do something. You could print it out, whatever, right? Like that. Or you could add it to a sum or whatever. Otherwise, we would use an index. For int I is equal to 0, I is less than the length of the array, so a dot length I plus plus. Now I'm going to do something that's going to look a little bit weird. It's unnecessary for our purposes here, but just roll with me. There. Now these two chunks of code are exactly identical. They do the exact same thing. Because what this is doing is it's copying each element into a new variable called value. Just like what this is doing, right? That element gets copied into this temporary variable, and then we print it out. Now, if we're going to write an index-based loop, would we bother copying it into a temporary variable? No, we would probably just print out a subscript I, right, and get rid of that. But I wanted to show you how what's going on behind the scenes in this is exactly that. And there's something that implies, which is that if you try to change value, it doesn't change the original array, right? Because what if I did this? Value is equal to 99, 990, whatever. Is that going to change anything in here? No, it's just changing the value of a temporary variable, right? Doesn't touch the original array. If I wanted to touch the original array, I'd have to do something like this. I'd have to do a subscript I is equal to 99. Something like that. But, unless I do that, it's not touching the original array. Similarly, if I did this, value is equal to 99. Well, value is just a temporary variable. It's not going to change anything. Yeah, we set it equal to 99, but it doesn't touch the original array. So although this is not a read-only variable, you can kind of think of it as being one because it's just a temporary variable that holds a copy of the content of that element. And whatever you do to it at that point does not affect the original array, just like this would not affect the original array. So I guess I'll make a comment here. You can change, or you can assign Now I wish I hadn't chosen value because I'm going to be writing something like you can assign a new value to value. Okay, you can assign value a different number, but it will not touch the original array. Consider it as read-only, even though it's not. Because changes to it do not modify the original array. So that's our for each loop, which for the C++ students, that textbook calls it a range-based for loop. And you Python people saw it in the syntax for value in A, right? Print value. That's what it looked like in Python. And in In C sharp, it looked like this. I like this syntax. For each, parentheses, int value in A, you know, then however you print it out in C sharp. Like that. A lot of languages have the same syntax. That's the Python way, that's the C sharp way, this is the Java way, right? That's the one that we want to know. But I know half of y'all have taken Python, so just wanted to relate that. What's the advantage of that loop? It's just faster to write. That's one advantage, and the other is if you replaced the array with a different data structure, like an array list, then you wouldn't have to change the syntax of your for loops in order to access them. All right, so chapter 9, quiz questions. The book uses the acronym ANSI as a mnemonic device. What does it stand for? Arrays, no. Strings, yes. What is that really talking about? Whether you put parentheses after dot length when you're trying to get the length of the array. If you call L dot length because you want the length of array L, then no parentheses. But if it's a string, you got to put the parentheses. So if you're trying to get the length of string S, you do S dot length and then you put parentheses around it. What does your professor do? He just types it and then the compiler tells him he did it wrong and he adds the parentheses. All right, we did talk about selection sorts, so that's that quiz question. But which of the following is the correct syntax for accessing an element in a two-dimensional array? Is it A, B, or C?
A.
I believe it's A. Yep. This would be totally wrong because it's parentheses. And I've seen some languages that did it this way, and Java is not one of them.
Is C++ one of them?
I was trying to remember that. In the book, what example is given for, I don't know. Keeping track of rainfalls using longitude, oh, forget it, I don't care. Okay, so we're actually at the end of the chapter about arrays, but I don't feel like we ought to be done with arrays yet. What I'd like to do is to do something with a two-dimensional array, and then we display, ask the user whether they want their dot to move up, down, left, or right, and then we're going to change the position of it on the array, right? Maybe we'll start it off right in the middle, and we'll print an asterisk followed by, a different number. And then as they pick which way they want to go, then we will update the data in the array, and we will print it out every loop. So I think
Pong.
we're good. Pardon?
Play Pong.
Yeah, but more like one of those adventure or wandering games where you're wandering through a dungeon or something like that. So we're going to create like a 9x9 array. And it's going to be all zeros. And when we print it out, if the number is a 0, then we're just going to print a dot. And then maybe we'll pick a different value for something else, like our character might be a 9. So let's go. If you want to play along, that's fine. If not, that's also fine. We are on lecture X. So I'm actually going to declare, maybe we should write this as a whole new class. Yeah, why not? So I'm going to come up here and I'm going to do what I always tell you not to do, which is put two classes in the same file. I'm going to call it class maze. Stupid name for it because it's not really going to be a maze, but maybe someday we'd be awesome enough to make it one. And we need to create an array. So int square braces, I'm just going to call it data, is equal to new int, let's make it a 9x9 array. So down here in main, we need to create class of that type. So maze m equals new maze. And then how about just m dot run? That's enough. So we're going to have to go and add a run method to our maze class. It's not going to do anything yet. I'm pretty sure I'm also going to want to add a print method. But what's run going to do is just going to be a loop. But for now, public void run, parentheses, in parentheses. Let's just print a message that says running, and we'll fill it in later with something good. System dot out dot print line running. So what I'm thinking we need is not only a grid with which to move ourselves around in, but we need to keep track of our current position, right? We're going to need to know where we are in that grid. We're going to need an X position and a Y position. So those will be two more member variables of our maze. So int xpos, comma ypos. And when we start off, let's just set ourselves off to the middle of the screen. If we're going from 0 up to 8, then 0, 1, 2, 3, 4. I think it'll be position 4, will be right in the middle of it. So int xpos is equal to 4, ypos is equal to 4. So we need a method that'll print the array so that we can print it after every move the user makes. And when we're printing the array, if the value is 0, we're just going to put a dot, kind of indicate a blank. Or let's not even make it that fancy. Let's just go ahead and print it if it's a 0. So public void display or print. What's a good word? How about print? It's just going to be a doubly nested loop, like we always do when we're dealing with two-dimensional arrays. And I could hard code the 9 and the 9 in there, or I could do it the more correct way, and I could ask the array how big it is. So that's what I'm going to do. So for parentheses, int r for row equals 0, r's less than data dot length, r plus plus. And then inside the nested loop, for int c is equal to 0, c is less than data subscript r dot length, because we want the length of that row. The first one returns us the number of rows. This one here. If you call data dot length on a two-dimensional array or a three-dimensional, it's returning the number of rows in it. And this will return the number of elements in that row. So let's system.out.print that value. So that's going to be data subscript R in subscript, subscript C in subscript. And it's giving me grief. It's underlining stuff. Oh, what did I forget on that line?
The increment or whatever.
Yep. I need to do semicolon C++. All right, and after the end of my inner loop, I need to print a character turn, right? Because I want to print out, 9 columns of information, then I want to hit like enter on a keyboard. Print some more. So here we just need to do a print line. System.out.print line. And what is run going to do? It's just going to call print right now. That's enough. But it's going to get more sophisticated, right? Because we're going to check to see what position we are currently on. And if our row, comma, column indicator matches our current position, then we're going to print something other than a number. How about an asterisk? But anyways, let's run it. Hopefully it'll print, yep, there's our 9 by 9 array. But what I'm going to want to do is have an if statement here. that if R and C equal to our current, now instead of X position and Y position, maybe I should have called it R position and C position, but I think you can get the idea that the X position is the columns, right? And the Y position is the rows. I guess I'll change it.
Someone has his hand up.
Yeah, so position underscore R for row, I'll be right there. And then position underscore C for column. There. All right.
Sorry, my interrupted.
Well, what's it say when you hover your cursor over there? Package M does not exist. This stuff needs to be inside main. Just cut that and paste it in under main. So what am I going to do? You know, we're printing out each spot on the map, but when R and C are currently equal to our player's position, we're going to print out something other than that number. We're going to print out an asterisk. So I need an if statement here. So here in my inner loop, if POS underscore R, position of the player, equals R, ampersand, ampersand, POS underscore C equals C, then system.out.print an asterisk. System.out.print, quote, asterisk, end quote. Else, print that other thing out. So when we run it again, hopefully we'll see an asterisk in the middle of our little field of zeros. Yep, right there. And then we're going to ask the user which way they want to go, up, down, left, or right, or north, south, east, and west. And then we're going to update everything. And maybe we'll leave a number behind as we go. Y'all ever play those snake games where you're moving the cursor keys around and your snake keeps getting longer and longer and longer? So,
Is that a star inside that?
pardon me?
I can't see that first print line. Is that a star?
That's an asterisk, yes, yes.
Question.
Sneeze. Did you say all this is supposed to be in Maine?
No, the only thing that's in main are these two lines of code. You doing okay? You need my eyeballs?
Yeah, I need eyeballs when
All
you
right,
get
let me come look.
Question.
Maybe I'll do that. This dot print.
So in our basic coding, this isn't really that necessary, right? But when you get to larger, more complicated, like thousands of lines, then you'll need this a lot because
This is nice because it'll pop up a list of things, but the only time it's mandatory is if you have variables with the same name as the element you're trying to access, and you need to distinguish between whether it's a member of the class or a local variable or something like that.
so you use the naming to reference what you have inside the
That's exactly what it's for. It's by specifying that, we're saying that whatever follows is a member of this class.
okay.
All right, so let's put this in a little while loop. We're going to ask the user what they want to do. So while true, we're going to make it one of those, oops, we're going to need a scanner. I should probably declare the scanner outside of this method so it'd be available elsewhere. But anyway, scanner sc equals new scanner parentheses system.in. Add the import for java.util.scanner. And so then while true. And inside the while loop, I want this dot print. I want to display the map. And and then I want to ask the user what they want to do. System.out.println, parentheses, quote, north, south, east, west, or Q. Quit. So let's get that choice. String has to be capital in this language. Choice equals sc.next line. C's in parentheses. And I think I'm going to just implement south for now, right? Or actually, I need to implement the quitting as well, right? So if choice equals Q, we're just going to break out of the loop or return out of the method. Either one of those things would work. So if parentheses choice dot equals ignore case parentheses quote Q end quote, then break because we're done. All right. I'm going to run that just because I'm not expecting it to do anything useful, but I want to make sure I don't have any syntax errors so far. So north, south, east, or west. I'm going to go north, whatever, south, whatever. It's not doing anything. That's all correct. Q, and it quits. Alrighty. Now let's check for S, meaning south. And if what's going to happen when we go south, we're going to increment our row counter, or our Y position, by 1. So if choice dot equals ignore case, quote S, in parentheses, or end quote in parentheses, we're going to call a method called south. So this dot south. We don't have a south method yet, obviously. We're going to have to go and add one. So I think what I'm going to make the program do is that when you move, it's going to write a 1 to the array to indicate where you've been, right? And then it's going to update our new position. So down here, right, this is the end of our class, right? It always helps me if I put, little comments, and this is the end of run. So end of run method. After the end of run method, but before the end of the class, or up above the run and print method, it doesn't really matter where we do it. Public void south, parentheses in parentheses. And so what are we going to do? We're going to leave a dot where we were sitting. So data, and we have 2 variables indicating our player's position. This dot row position or X position, if that's what you probably call it Y position. It doesn't matter as long as you do it just keep track. Here, when you were printing it out, did you compare X or Y to R? And did you compare X or Y to C? I think most people went ahead and changed their pointers to be R and C. If you didn't, well, then we'll fix it in a minute. So anyways, the data at this position, this dot POS underscore R, because that's our row, end element, open element, this dot POS underscore C, our current column, equals 1. Right, we're replacing that 0, we're putting a 1 there, just to indicate where we've been. And then, what do I need to do to my position counters? Right, if I'm going to indicate that I'm going down, Am I gonna increment my R? Am I gonna increment my C? Am I gonna decrement one of them? What am I doing?
You would increment it by the row.
Yeah, so I need to update my row. So this dot POS underscore R plus plus. Now our program's gonna blow up pretty quickly. We're gonna run it, and then our character's gonna run off the edge of the screen. I mean, off the edge of the map, and it's gonna blow up. We'll have to handle that. That's okay.
We'll worry about that at this time.
So end south method. All right, so I'm going to move south, and my guy blipped down one, and he left a one behind him. I'm going to move south again. He blipped down again. South again. He blipped down again. South again. He blipped down yet again. South one more time, and he's off the edge of the map. We can't see him. And then south one more time, and kablooey. What happened is it tried to write a 1 past the bounds of the array. So we should probably make it that after we move, we double check ourselves, and if we're past the edge of the array in any direction, then we need to bounce ourselves back 1, right? So once our, if the row becomes -1, we want to push it back to being 0. Or if the column is greater than the maximum size of the number of columns, we want to put it back 1.
Why did the program do that, but when it got to that point,
Well, let's do this.
why did it not do it at the previous time?
You look at
Very
what
good
you
question.
write Once for
Pardon me?
you had to put it in twice.
Exactly. Let me see if I can illustrate that, and then I'll get up on the board and I'll wave my hands around. So system.out.println, let's print out POS underscore R plus a space plus POS underscore C. That shows our current position before we move it. And so now when I run it, that's a very good question, guys, because I was actually surprised. I thought it'd blow up at that point too. So it took me a second. So south, 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 south. All right, I'm at this position. I haven't written anything into that square yet. If I could pick the asterisk up, there'd still be a 0 in my array there. So at position 7 underscore 4 is where my position counter is. And when I move, this is the position that's going to get filled in with a 1. It's going to fill in row 7, column 4. So 0, 1, 2, 3, 4, 5, 6, 7. Oh, that's where it was. This may not be giving the best example. Let's see if it helps. Okay, so now we have filled in our last position on the screen. I know what change I need to make. Let me stop it, update it. Okay. So I'm going to put before move, comma, like that. You don't got to do this. And then after move, there, like that. All right, so as he moves down, south. Before the move, he was at 4-4, and that's true. Now he's at 5-4. 4-4 is where the 1 got written. We're going to move south again. He was at 5-4, that's true. We wrote a 1 to 5-4, and then we updated his position to 6-4. But we didn't change the array at that point. This is the only place that's actually changed the array. So we're going to move south again. We were at that position, so we wrote a 1 there, and then we added 1 to our row to get ourselves to 7-4. Go south again. We were at 7-4, which is there, so we wrote a 1 there, and then we updated our row counter to 8. Now here's what looks like a mystery, but it's not. We go south one more time. We write a 1 out to position 8 for 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's position 8, 4. That's where we wrote the 1. And then our position is now 9, 4. But we haven't written anything. But that means that the next time we move, that place is going to get a 1 written to it. Does that make sense? And that is out of bounds. So it looks like we're moving past the end of the array. What's really happening is that this is our position C counters are indicating the next place it's going to be written. And since this is a 9 by 9 array, the only possible values are 0
If you
through
try it
8.
one more time, what would it,
Now it's going to blow up.
what would it print? Would it,
Well, it's going to print 9, 4, and now it's trying to write a 1 to position 9, 4. But it can't because there's only 8 rows. Row 0,
So it
1,
did-
2, 3, 4,
so
5,
it
6,
got to
7,
the
8.
before move, but
Exactly.
it didn't do the after move.
Right, so right here, we were able to print it out, but we have invalid values. So I think what we ought to do is after we move, we ought to correct our position. And what does correcting our position mean? It means if the value is 9, then go back to 8, right? Or if it's equal to the length of the array, then set it equal to 1 minus the length of the array. And we're going to have to do that no matter which way we're moving, right? So why don't we, or we just put an if statement right here, right? If we are already at the edge of the array, we're not going to move ourselves. I think that's a better solution. So if, parentheses, this dot POS comma R is greater than or equal to the number of rows, so data dot length tell you what, let's make it less than. I'm not sure this is going to fix it. I think it'd be better to have I think that this is not going to work. But if our position is less than the length of the array, then I think it's going to blow up just as it did before. I don't think that this is an adequate fix. Let's find out. All right, here I am at the edge of the array. Is it going to, yeah, it moved me right past the end of the array, right? Because I don't see an asterisk on here anymore. And so if I do another south, well, it's stopping it from blowing up.
But it's still keeping you off the grid.
That's what I'm thinking. How about if we made it length minus 1? Right, because we actually don't want to move past the point where our row number is equal to 8. So I'm changing that to minus 1. And I think that'll keep us on the map. And really what we ought to do is to cut this system out, system print line, and put it above the if statement and the other one after it. So if you have those, no guarantee that you typed as much as I did. That. South, 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 south. And he stops.
What is that? So it's,
Well, let's implement a north then.
or maybe we could do something that instead of trying, we could print saying, sorry, can't move south.
Yeah, we could put an else and print system.out.println can't move past edge. Yep, can't move past edge. Nice. We're probably going to wind up deleting these after move comments, right? Because we know it's working. But I'm going to leave them there just a little bit more. So now we need to write a north method. It's going to look almost exactly the same, except it's going to be minus minus rather than plus plus. So I'm just going to copy the entire chunk of code and change, copy, paste it, change south to north. Alright, I need to make a couple of changes. If I'm moving north, I don't plus plus my row number, right? What do I do?
Minus minus. That's what you would do.
Now there's another bug. It's going to blow up like it did before. You can probably predict that. Oh, I haven't added the code that would actually call the north. So I'm going to have to go down to my run, and I'm going to have to put another if statement that'll call north. So make sure that you've changed the name to north and that you've done the minus minus, and if you know the other fix, great, go ahead, but I'm not going to make it yet. And down here in my run method, wherever that was, here we go. Could set this up as a switch case if we want to be really fancy. Anyways, if choice dot equals ignore case, parentheses, quote, end quote, this dot north. So south, 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 great. North, 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 north. Oops. After that last move, he's now at position -1. We know what's going to happen there. It doesn't matter which way he moves again. He could try to move back onto the map, but it's too late because we're standing at -1, 4. So when we move off that spot, we write a 1 to the array there, and it's impossible, and so it blows up. So what should we do? We're not going to be... Here's our north function, wherever it was. I need to fix this. What should that be?
0 is greater than 0.
Yeah, let's try that. I'm wondering if it needs to be 1, but let's give 0 a shot. North, 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 north. Oh, it's not doing anything.
That may be because go up, you may have called it. You may not even go up to where you have the method sign, may not say 2.
No, what's happening is that our position R starts off greater than 0, and so
It needs to be a greater
Maybe-
than sign.
gotta be greater than. Greater than... What did we have originally? That's what we had. If it's less than data length and this .pos underscore R is greater than 0, then it's safe to move. Almost, and now he's at the edge. Can't move past edge. Okay, so we caught him. And we could add an east and a west the same way, except instead of moving, right, position R, we'd be moving position C. You feel like doing that? Is that fun enough?
I guess we could.
Yeah, why not? Why not? Okay, so to do that, I'm going to copy, I'll be right there. I'm going to copy the north and the south functions and paste them again and change their names to east and west. and then start making all the changes necessary. Feel free to do that if you don't want to wait for me. Just copy north and south methods, paste them, and change their names to east and west, and make the changes you think are necessary. Move your mouse over here. What's oh, we're gonna need another close embrace.
Boy, that was cool. I'll do this. Hey, what I do is, this is what I do. Yeah, so I went over I realized I can't. Here's a movie. It like gets stuck at that position.
Good point. I'll have to diagnose that up here. All right, do you find that once you hit the edge, you can't move anymore? Even without any changes to it. I'm going to see if that's the case. Once I go to the edge, am I stuck? So I'm going to go south, 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 south. Well, I can't go any farther. North. Nope. North. Nope. North. Nope. North. I think my north check is a little bit broken.
Yeah, because I was able to go all the way up north, and I could move back south. It just
Right. So my if statement on north is a little bit broken. How about we take this part off? We only need to make sure that our position is greater than 0 before we subtract 1 from it. So I'm going to get rid of that. And I think that'll fix the problem. Good. Very good catch. So when I copy and paste it, or if you've already copied and pasted it, you're going to need to make, that fix in your east method as well. So I'm going to do that. I'm going to grab north and I'm going to paste it. Whoops. I need to correct my comments. Your comments always wind up being wrong when you copy and paste code. I'm going to copy the north method and paste it and rename it to east. And what do I need to change?
Actually, might be better I think it would be better if you try that with the south method.
Okay, I'll do the south method. You're right, because I like moving down. So I'm going to take the south method and copy it.
That was more that the if statement would be, you wouldn't have to do as much. You just
So, yeah, you're right. Okay, so south is going to become west. And what else do I need to do in my west method? We're moving west. We're not manipulating our rows, right?
so
We're manipulating our columns. So, I'm just going to change that to POSC. And then I'm going to add one to POSC. Really? That's all I had to make?
Isn't west to the
if
left?
this were no one choose north.
Oh, you're right, you're right, you're right. West is to the left.
You might want to do north.
So I'm going to undo those changes and I'm going to find
I thought you were east.
east and make it do those things. Okay, so where did I put my east method? Right there. All right, I see what Daniel was saying now, and I botched this. But I'm going to run with it. We're moving our columns rather than our rows. And what's our test condition need to be? If our position is less than the number of columns in this row. So, data, subscript, POS underscore R, in subscript, dot length. -1. I remember that -1 bit. I know we had to do that. Okay. Now going west will be easier. We're not gonna have to count the number, right? We're just gonna make sure that we're not wandering into zero. So we're just gonna make sure that the column indicator is not, equal to zero.
And then you do plus plus, right?
Well, I do plus plus here, yep, because we're going east. Now I'm gonna go find my west method and make those changes. So, if the column is greater than 0, it's safe to move. And then I'm going to make that C minus minus. Then I need to go and modify my run commands, right, to call these methods as well.
Well, one thing I didn't know until now is the C interaction we have created, so the width is double, the number of columns is double what it should be.
Oh yeah.
I don't know how that happened.
So I'm going to add 2 more if statements. I'm just going to copy and paste the ones I have and make one for going east and west. East, east, east. Okay, now when I'm calling east, he's moving south. Obviously cutting and pasting was not adequate. I was dumb. Alrighty. If you go east, you're supposed to call this dot east. And if you call west, you're supposed to go this dot west. And it's completely possible that I lost you, in which it's totally fine. I would have been lost if I was watching this. East, 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 east. Bump, we've hit the edge of the road.
I'm locked on the right wall.
So let's try going west.
And it's your dog.
North. Alright, now let's be super cool and implement going diagonal. Nah. We could.
Southeast.
This is how people implemented those games, roguelikes are what they're called nowadays, because the original Rogue game was written in the 70s, and it would draw a map of a dungeon entirely out of periods and stuff like that, and your character was a star, and he wandered around, and monsters would start running towards him.
Is that what you played as a kid?
I saw other people play it. I was more interested in writing the programs than in playing them at that point. Okay, so let me stop the recording, and to make this a little bit different is maybe when we're moving south, we leave 1s behind us, but when we're moving west, we leave 2s behind us. Or how's about each time we go over something, we don't set it equal to 1, we do plus plus.
That would be better.
So I'm going to change all of my little equals 1s to plus plus instead. Now this is going to mess up our display once our numbers get larger than 9, right? Because it's assuming that our numbers are 0 through 9. But I think this might be fun, watching it. Our numbers increase or decrease. Well, they'll never decrease. They'll always increase. Okay, so east, 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 east. Now he's going to go west. Now they're changing into 2s. North, east, south. See what it's doing? I like it. But like I said, if that number ever got to be larger than 9, it would mess up the display of it.
Oh, it's how many times it's been on that dot?
Exactly, how many times it's moved off that dot. Alright, that's enough of that. We'll close for today. So yeah, if you have any confusion over the topics we've been talking about, or you're stuck on a homework assignment or stuff like that, bring those questions to class on Thursday. And don't skip class just because you already understand everything. we'll try to make it interesting, and it could very well be that the questions will only last 10 minutes, and then I'll have to find something else to lecture about, in which case I'm quite capable of doing that.
Like more detailed object-oriented programming.
Yeah, we can cover more of that.
I think someone